Hello, Professor. My name is Juan Gutierrez. I am here with Danielle Valdez, Alfredo Noriega, and the following Panther IDs are 602-0378, 6099961, 5675845, and we will be presenting at 11:14 p.m. for March 18th, 2021 for a lack of good user communication with devices. Hopefully you like this project and our presentation. We will do our best to be able to satisfy the time and your needs. Hello, Professor. We will be talking about abstract. So during abstract, on this presentation, IoT introduces a variety of different options for bettering the use of microcontroller with specific devices. With the introduction to these methods comes problems, specifically the communication from devices to human observations. To challenge this approach, we will be utilizing a way to send signals to an RGB LED to allow us to observe the status of a device through a mini display such as an LCD. Whether it be a good, bad, or a neutral response would be extremely helpful to monitor a device and help lay out a solution to a problem if it occurs. For this project, we will be monitoring the RGB LED's universal colors, as it displays messages to the LCD display, so they will be changing colors. For this third slide, we will be speaking about methodology. What we need to do is gather the right components to create a system to maintain stable microcontroller operation. We will utilize the Arduino, an LCD display, an RGB LED, the breadboard, a potentiometer to toggle different system statuses, and a few wires and resistors to get the job done. So those are just some of the components that we actually used. And with these tools in hand, we can improve upon microcontroller monitoring for future purposes. Not only can we check for system failure, we would also check if a device is soon to be out of battery or if it's full. These type of examples can be building blocks to improve our observation performance with such devices. Therefore, we're going to write a program in which we can color code specific data and display that data to us through the LCD display. For each of these, they display a specific color, which we will use to see further into our project. For the fourth result evaluation, using the circuit presented below, we are able to control an LCD display and an RGB LED, allowing for both of them to work concurrently. This will in fact be used in order to show that certain operations/issues presented on a device could have some universal color coding done to ensure that if an issue were to arise with the device, there could be a failsafe on the device that could actually advise you to see what the issue is and show that to the user with something so simple as an RGB LED. The basics for the color coding was labeled like this: red is an error, yellow is low power, blue is standby, green is in use, and white is loading. Having a universal color coding system that IEEE endorse or recommend could allow for many IoT devices to have the same system of colors to determine what might be the issue that the device, and thus allowing for a much smoother customer and technician experience when describing the problem and solution. For the fifth slide and the final slide, we will be speaking about the circuit, and this is specifically speaking about the circuit board and the first Arduino project, with the YouTube link actually on here, which we will be clicking. But this is just to show you here what we actually have on Tinkercad. We of course made the presentation in person, that's why we have the YouTube link, but this is just so you can actually see a full-on diagram of what we did on Tinkercad to be able to make sure that this would work, since it is of course simpler on here.
Demonstration video portion of the project, where we have the LCD screen which will display. This is a demonstration video portion of the project, where we have the LCD screen which will display the message, and that message will correlate with what light the LED is going to light up with. The potentiometer is just to ensure that the LCD is at full capacity, and when I let go of the reset button, it will start with red being error, yellow being low power, blue being standby, green being armed or in use, and white being loading.